Previously, we have studied about the various methods by which we can measure the concentration of the solution. Now today, we have to do the various numericals regarding about the concentration of the solution. The first one is what is the molarity of 450.5 gram of the silver nitrate dissolved in 675 ml of water. Now in this case, we have to determine the molarity of the silver nitrate. The second one, how many grams of the sodium chloride is needed to make 34.2 ml of 0.87 molar solution. In this case, we have to determine the amount of the sodium chloride, that is the mass of the sodium chloride we have to determine. Now in this case, 50 grams of the sugar is mixed with 365 ml of water. Calculate the molality and mole fraction of the sugar. Now in this case, we are using the formula of the molality as well as the formula of the mole fraction to determine the molality and mole fraction of the solution. 50 grams of the sugar is mixed with 365 ml of water. Calculate the molality and mole fraction of the sugar. In this case, we have to determine the mole fraction as well as the molality both. You have 20% mass percent salt water solution of NaCl with a density of 1.04. Find out the molality and mole fraction. Here the mass percent is given to you, by which we have to determine the molality as well as molarity and mole fraction. Now come to the point. Solution of solid in liquids. When the solute is added continuously to the liquid solvent, the solute keeps on dissolving and the concentration of the solution keeps on increasing. This process is known as dissolution. Ultimately, a stage is reached when no more further solute can dissolve at a given temperature. This is because from the solution, the solute particle keeps on colliding on the surface of the solute particles and gets separated out of the solution. This process is known as crystallization. No more solute can dissolve because the rate of dissolution becomes equal to rate of crystallization. The process comes in dynamic equilibrium. Now at this stage, the solution is said to be the saturated solution. The solubility of the solid in the liquid at a given temperature is defined as the maximum amount of the solid in gram which can dissolve in 100 gram of the liquid to form a saturated solution at that particular temperature. There are various factors which generally affects the solubility of the solid in the liquid. These are number one, the nature of the solute, other is the nature of the solvent, and third is the temperature. As we know that the like dissolves like, this means that the solid dissolves in the liquid which is chemically similar to it. For example, the sodium chloride, which is polar, dissolved in the polar water solvent. Common salt is more soluble in water than the sugar. Iodine, a covalent substance, is more soluble in alcohol or carbon tetrachloride than in water. Why these substances will get solubilized in water? Now the reason for the ionic compound. The ionic compound being dissolved in the polar solvent because of the following factors. As we know, there are the strong electrostatic force of attraction between the ions of the crystal and the polar solvent molecule. The negative ion being attracted by the positive pole of the solvent molecule and the positive ion by the negative pole of the solvent molecule. Thus, the water molecule pulls the ions of the crystal apart and the electrostatic force of attraction which is existing between the ions of the crystals are cut off. The energy which is being required for the splitting of the ionic compound into its ion is called the lattice energy, and the energy which is given out when the ions get hydrated is called the hydration energy. The substance will dissolve only if the hydration energy is greater than the lattice energy. The second factor which affects the solubility of the solid in the liquid is temperature. Now the effect of the temperature is divided into three parts. Number one, we are having such type of the solutes in which we observe that those solutes whose solubility increases continuously with increase in temperature. Because the substances like sodium nitrate, potassium nitrate, sodium chloride, potassium chloride all fall in this category. All the substances show the dissolution process which is endothermic in nature. This means solute plus solvent plus heat gives solution. By applying the Le-Chatelet principle, as the temperature is increased, the equilibrium will shift in the direction in which the heat is absorbed, that is in the forward direction. Now the second type of solutes, those whose solubility decreases continuously with increase in temperature. There are the substances like cerium sulfate, lithium carbonate, sodium carbonate monohydrate, whose solubility decreases with the increase of temperature. The dissolution of the substances is exothermic in nature. Third, those substances whose solubility does not increases or decreases continuously. For example, when we are taking sodium sulfate decahydrated, first it will increase its solubility up to 32.4 degrees centigrade, and then it begins to decrease. The temperature at which the one form of the substance changes into another form is known as the transition temperature. Now here we have to show the solubility, why the solubility increases, why the solubility decreases. They generally depends upon the process of the dissolution, because we know that if the dissolution of the solute is endothermic, therefore the solubility will increase by rising the temperature, and if the dissolution is exothermic, then definitely the solubility will continuously decreases with increase in temperature. Now we want to show the solubility curves to you. These are the solubility curves. Now what are the solubility curves? When we plot the solubilities against the temperature for the different compounds, then we get the curves, and these curves are known as the solubility curves. Now in these solubility curves, there are the certain substances like calcium chloride, sodium nitrate, lead nitrate, potassium nitrate, where the solubility is continuously increases. But in some cases, where we are getting like cerium sulfate, lithium carbonate, sodium carbonate monohydrate, the solubility continuously decreases by increasing the temperature. Now we have to observe the solubility of the gases. Now what do you mean by the solubility of the gases? The solubility of the gases in a particular liquid is the volume of the gas in cc that can be dissolved in unit volume of the liquid to form the saturated solution at the temperature of the experiment and under a pressure of 1 atmosphere. That represents the solubility of the gas. The solubility of the gas will depend upon three factors. Number one, nature of the gas and the solvent. Number two, the effect of temperature. Number three, the effect of pressure. The nature of the gas and the solvent. The gases like hydrogen, oxygen, nitrogen, they dissolve in water only to a very small extent, while the gases like CO2, HCl and ammonia are highly soluble. This is because these gases show their reaction with the solvent. Now the effect of temperature. The solubility of the gases decreases with increase in temperature because we know that the dissolution of the gas in a liquid is an exothermic process. Therefore, when gas reacts with solvent, gas plus solvent gives the solution plus heat. Now, applying the Lee-Chettier principle, it is evidently that the increase of temperature should shift the equilibrium in the backward direction and the solubility will decrease by rising the temperature. Now, what is the effect of the pressure over the solubility of the gas? The solubility of the gas in a liquid at a particular temperature is directly proportional to the pressure of the gas in equilibrium with the liquid at that temperature. In another word, we can also say that the mass of the gas which is dissolved in the given volume of the liquid at a constant temperature is directly proportional to the pressure of the gas present in equilibrium with the liquid, where m is the mass of the gas dissolved in a unit volume and P is the pressure of the gas in equilibrium with the solvent. Then m is directly proportional to P, or m is equal to Kp, where K is the constant of proportionality here. And this law is known as Henry's law. The Henry law can also be explained in another words, the partial pressure of the gas in vapor phase is directly proportional to the mole fraction of the gas in the solution. That is, P is equal to KHX, where X is the mole fraction of the gas in the solution and P is the partial pressure of the gas in the vapor phase, where KH is a Henry's constant. Now when we plot the graph between the mole fraction and the partial pressure of the gas, we get the straight line which is passing through the origin. This represents that the slope of this is KH, which is known as the Henry's constant. The Henry's constant is the function of the nature of the gas. Greater the value of the KH, lower is the solubility of the gas. At the same partial pressure, the value of the KH increases with increase of temperature, which implying that the solubility decreases with increase of temperature at the same pressure. Now the limitation of Henry laws. The Henry law is applicable only when the following conditions are satisfied. The pressure should be low and the temperature should be high. Number 1. Second, gas should not undergo compound formation with the solvent or association or dissociation in the solvent.